the summer of 1898, police and ambulances converged on a quiet block in Lower Manhattan. Witnesses swore the ground had shaken. Windows rattled. A building seemed ready to come apart. And when officers finally reached the source, they found no crack in the earth, no fault line, no seismic event of any kind. They found one man standing beside a small metal device, holding a sledgehammer. That man was Nikola Tesla, and the device fit in his coat pocket. By the late 1890s, Tesla was already one of the most talked about inventors in America. He had helped bring alternating current into homes and factories. He had lit Niagara Falls. But in his own mind, his most important work wasn't finished. It was just beginning. He was obsessed with a single idea. That vibration, precisely tuned, could move enormous amounts of energy through solid matter, almost for free. Out of that obsession came a strange little machine, one that would earn him a patent, a headline, and eventually a nickname that still follows him more than a century later: the earthquake machine. The device itself was unglamorous. Tesla called it a mechanical oscillator, and on paper, it was simply a steam-powered engine. He patented the core design in 1893, years before the incident that would make it famous. Steam pushed a piston up and down inside a sealed cylinder, and that piston was tied to an armature that vibrated at extremely high speed. Tesla's actual goal was practical. He wanted a compact way to generate electricity, and the oscillator was, at its heart, an electric generator built around rapid mechanical vibration rather than a spinning turbine. But Tesla being Tesla, the invention didn't stay in the realm of practical engineering for long. He started asking a different question. What happens if you tune that vibration to match the natural frequency of something much larger, like a building? This is where the story usually jumps straight to disaster. But the more interesting version is slower, and it comes almost entirely from Tesla himself, told decades after the fact. According to Tesla's own later account, he clipped a small oscillator onto a support beam in the building, housing his Houston Street laboratory. He wanted to see whether he could bring the device into resonance with the structure itself. He described turning the frequency up in small increments, what he called notch after notch, and hearing the building begin to creak. He kept adjusting. The creaking grew louder, and by his telling, the machinery in the lab began shaking violently before he grabbed a hammer and smashed the device to stop it. Outside, according to newspaper accounts published decades later, the commotion was enough to draw police and ambulances to the block, with onlookers believing an earthquake had struck. Here's where the story needs to slow down, because this is the point where most retellings quietly blur two very different things: what was recorded at the time and what Tesla said about it years later. There is no known 1898 newspaper report describing an earthquake on Houston Street. The most detailed version of this story doesn't appear until 1912 in a magazine profile, and an even more dramatic version, including a claim that he tested a similar device on a half-built steel structure near Wall Street, surfaced in a 1935 newspaper interview when Tesla was 79 years old and eager for publicity around his birthday. That doesn't mean the event never happened. Tesla's assistant, George Scherf, is named in some historical accounts as having been present. But it does mean that the most vivid details, the panicked steelworkers, the police descending on the scene, the boast that 10 more minutes could have leveled the building, come to us filtered through an aging inventor telling his own legend, not through a police report or a same-day newspaper account. Historians who have studied Tesla's life closely, including biographer W. Bernard Carlson, treat the story the way they treat much of Tesla's later self-mythology, probably rooted in something real, almost certainly polished in the retelling. So strip away the legend for a moment. Could a small mechanical oscillator actually shake a building hard enough to alarm a city block? The physics answer is more interesting than a flat yes or no. Resonance is real, and it's not exotic. Soldiers break step crossing a bridge for exactly this reason. A rhythmic force applied at a structure's natural frequency can build amplitude over time, even if each individual push is small. Tesla understood this principle better than almost anyone working in engineering at the time, and it genuinely was central to his research into transmitting energy through mechanical vibration. But turning a startling noise and a shaking beam into a structural collapse is a much bigger leap. Modern engineers who've examined the claim generally agree that a hand-sized steam oscillator could plausibly rattle a wooden-framed building or a section of iron scaffolding enough to unnerve people nearby. Bringing down a fully occupied steel structure is a different order of magnitude entirely. In 2006, a well-known television show built its own version of Tesla's oscillator to test the claim directly. Their device produced vibrations that could be felt at a real distance, but nothing close to structural failure, even on a dedicated test bridge. They rated the story as busted, at least in its most extreme form. What's easy to miss, in all the talk about earthquakes, is what Tesla actually intended to do with this technology, and it had nothing to do with destruction. He filed patents describing a system he later called telegeodynamics, a way of sending vibrations through the Earth itself and picking them up somewhere else, potentially transmitting energy or signals without wires. It's the same instinct that drove his wireless power experiments at Colorado Springs and Wardenclyffe. The belief that the planet itself could act as a conductor. The earthquake demonstration, real or exaggerated, wasn't the point of the invention. It was a side effect Tesla discovered while chasing something bigger, a world where energy moved invisibly through solid ground, the way he believed electricity someday would move through the air. That larger project never worked. The oscillations lost too much strength, traveling through real soil and stone, dampened long before they could travel useful distances. Telegeodynamics stayed a patent and a demonstration, never a working system. By the time Tesla told his most dramatic version of the story, in 1935, his fortunes had changed dramatically. The man once backed by Westinghouse and courted by investors was living alone in a hotel room, increasingly known more for outlandish claims, death rays, world-shaking machines, than for verified engineering work. That context matters. It doesn't make the earthquake machine a lie, but it helps explain why the story grew more cinematic with every telling, arriving in its final form from a 79-year-old inventor talking to reporters who were only too happy to print it. So what actually happened on Houston Street in 1898? The honest answer is, something did. A small machine, a resonating beam, enough noise and shaking to draw a crowd, and possibly the police. What we don't have is a contemporary account confirming the scale of the story Tesla told decades later. The terrified steelworkers, the near collapse, the boast about the Brooklyn Bridge. What we do have is a real invention, a real patent, and a real scientific principle that Tesla understood with unusual depth, that small, precisely repeated forces can move enormous things, given enough time and the right frequency. Maybe that's a more interesting story than the myth. Not a machine that could split the earth in half, but a man who kept discovering again and again that the smallest disturbances, tuned correctly, could shake something far larger than themselves